Welcome to Introduction to Arrays. In the last session, we discussed about collections, the general concept, or we discussed arrays as part of this general concept called as collection. So collection is more general. Now we go to arrays. So this is how collections are supported. This is how collections are supported by the C language. Arrays. C language supports collection in the form of arrays, and an array is a homogeneous collection of elements. 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 So this is important point. It is a collection of elements. It is a collection of elements. What type of elements? They are homogeneous. Homogeneous. In programming terms, in C language programming terms, it means all these elements which form an array, which form a single array, are of same data type. That means an array consists of collection of elements which can be either integers, real, characters, maybe strings also. But an array cannot contain both integers, real numbers, and maybe these characters, etc. So an array can be integer array, an array can be a real or floating point array, an array can be character array, an array can be a string of collection of strings also. So but the elements of the array are of same data type. So if elements are of same data type, definitely they have similar attributes. That means integers. If it is an integer array, all the elements will have same attributes. They are basically integers. No fractional part. So they can be manipulated similarly. That means you can perform addition of integers, multiplication of integers, etc. So the attributes of the operations will be same, or at least similar. Okay. So you can perform the same operations, or you may perform different operations depending on the requirement. But operations performed are similar. At a global level, operations performed are similar. Okay, depending on your requirement, you may perform some operations and you may not perform some operations. So by definition, since it is a collection, there should be at least two elements. So if it is an individual element, one element, then you can represent it as simple variable. If you have two elements, then you can represent it as an array. But usually we don't consider arrays with two elements. 10, at least our array elements will have 10 elements, 20, like that. One important property of arrays is the number of dimensions. Okay, number of dimensions. If there is only one dimension, then it is called as single dimensional array. Only one dimension, then it is called as single dimensional array. If there are two dimensions, then it is called as two dimensional array. In general, if there are n dimensions, then it is called as n dimensional array. In general, if there are n dimensions, then it is called as n dimensional array. Most of the applications which operate on arrays use only 1 and 2 dimensional arrays. So we only use only 1 dimensional and 2 dimensional arrays. Of course, we are permitted to use 3 dimensional arrays, 4 dimensional arrays also. But generally we don't use them, except in rare cases, maybe when you are dealing with the weather forecasting, when you are dealing with spatial data, 3-dimensional space, 4-dimensional space, etc. Then we go with more dimensions. But usually we restrict ourselves to 1 or 2 dimensions. In simple terms, one or two dimensions are nothing but there can be a row of elements. There can be row of elements, single dimension. There can be rows and columns. Both are there. So two dimensional. So there can be rows, columns, and then say pages. So there are number of pages within the page. You have rows and columns. In that case, you go with three-dimensional arrays. Maybe you want to represent points in three-dimensional space. In that case, you require three coordinates actually. All such points form three-dimensional array. Dimensions are only for logical organization. Physically, all the elements of the array are stored in only consecutive locations. So, dimensions are only for logical organization. So, usually the elements are stored one after the other. So, first element, that means first row elements, second row elements. So, in sequential locations, first row elements and then continuation, second row elements and then third row elements, the fourth row elements, like that. So, we have seen the chart of this memory. So, in consecutive locations. So, in C language, the array elements are stored in consecutive locations only. That means contiguous locations. Declaring an array. So in C language, similar to any variable, array has to be declared. So you all know that in C language, declaration is mandatory. Even if you use variables, you have to declare it. If you don't declare, compiler is going to generate the error message. Similar the case with the arrays also. If you want to use arrays, then declare them. But in addition to specifying the name of the array, whenever you consider the variable, you only specify the name. So for array also, you have to specify the name. But in addition to specifying the name of the array, we have to specify the number of dimensions also. We have to specify the number of dimensions and also the size of each dimension actually. And also the size of the array or size of each dimension actually. So we have to specify name and also size. Name and size. Name is nothing but again a valid identifier, similar to variable. Variable is a valid identifier. Name of the array is also a valid identifier. But that name is common to all the array elements. You don't use different names. But that name is common to all the array elements. And how do you access the individual elements? By using indexing. So an array name is a valid identifier. Which is common to all the elements of the array. So if you want to declare an array, this is the format that is used. This is the general syntax that is used. Single dimensional array is declared as follows: storage class, data type, array name, max size, terminated with the semicolon. Storage class, we have not discussed it yet, but storage class can be auto, extern, static, register. They are the storage classes that are permitted. What is the significance of storage class? When the memory is reserved, when the variable value is valid, etc. That we will study at the end. But for the time being, you just consider that storage class has to be specified, but it is not mandatory in most of the cases. In most of the cases, we avoid it. And what is called as default storage class, auto, is taken. Data type is nothing but any data type that is supported by the C language. It can be a basic data type, it can be a derived data type, it can be a user defined data type. Basic data types like integer, float, etc. So you can specify other data types also. Okay. You have this type def, typedef, that I think we discussed. Using it, you can declare user defined data types. So we'll see. They can come here. Those data types can also come here. So initially we restrict ourselves to only int, float, char or double. but we can have user defined data types also. Array name is a valid identifier. It is up to you. It can be X, it can be A, or it can be array name itself without the hyphen also, array name, or with the hyphen array name. I think with hyphen is not permitted, underscore is permitted. Array underscore name, array underscore name, or it can be array name. It can be anything, roll numbers, students, etc. And max size, that means what is the maximum number of elements which you are going to store. So this is one of the issues with the array. So you have to specify the maximum number of elements that can be stored in the array. That is mandatory. You may store maximum size number of elements, or you may store the elements number of elements which is less than the maximum size. Say if you have 10, you may store 10 elements, or you may store only 5 elements. But you are not supposed to store more than 10 elements. That means if you declare it as an array of 10 elements, you cannot store 20 elements. But there is one issue with the C language. C language doesn't do range checking. That means it doesn't check whether you are storing it within the limits or not. That is one problem with the arrays in C language. But anyhow, you generally don't do it actually, because you are aware that you can store only maximum size. But that can be sometimes a problem. So max size is actually the maximum number of elements. Okay. Total memory reserved. How much memory is reserved? We discussed that you have to specify the max size. The memory will be reserved. Array is stored in consecutive locations. Okay. Memory is reserved during the compilation time. You have to specify the maximum size. Okay. So memory is reserved during compilation time. Memory reserved is in consecutive or contiguous locations. Okay, those points please remember. But the actual memory that is reserved depends on the size of the data type. So the max size star size of the data type. So in the case of integer, say if it is 2 bytes, assuming 2 bytes. So if you specify the array size, max size as 10, then 10 into 2, that is 20 bytes will be reserved. In the case of floating, if it is 4 bytes, 10 into 4, that is 40 bytes will be reserved, and 40 bytes should be available in the memory. So accessing the individual elements of the array, okay, I have declared it, but how do you access the individual elements of the array? Individual elements of the array are accessed by indexing. Individual array elements are accessed by what is called as indexing. So integers are used as indexes, and indexes are positive only. The one important point which you have to remember, which is little confusing, is so in C indexing starts at 0, not at 1. In C indexing starts at 0, not at 1. That means if you have an array of 10, then the array elements are actually stored from 0 to 9. Array name of 0 to array name of 9. Please note that point. But you need not always start from the say 0th position. You can actually have an array element stored from 1 also. For convenience, we will be storing from 1. But remember, you can go up to only max size minus 1 location. 10 means 10 minus 1, that is 9th location, because values are permitted to be stored from 0 to array of 0 to array of 9 only. But you can store the elements, need not be from 0, but you can start from 1, but you cannot go beyond that 9. So array elements are stored from 0 to max size minus 1. Ith element can be accessed ith element, if we start storing from 0, ith element can be accessed by using array name of I minus 1, array name of I minus 1. If you store from say 1, then so ith element can be accessed by using array name of I. That is little confusing. But please remember that point. That is important. So that is important. So you can initialize the array like this. Arrays can be initialized. So general format is storage class data type array of max size, the declaration, but equal to values specified in the flower brackets. And remember, we use square brackets to represent the array. If there are values, they are enclosed in flower brackets. So if the array is initialized during the declaration, then we can omit the max size, and depending on the number of values in the value list, array size is set appropriately. So you can specify like this, but generally we don't do it. The best method is using loops. So you initialize the arrays. Next, input and output. C doesn't support any built-in functions to read and print all the elements of the array. So C doesn't support any built-in functions to read and print all the elements of the array as a unit, except in the case of strings. So you can read the strings, you can read the array elements by using this syntax like this. You can print like this. Ampersand array name of I, printf array name of I. So this is how you do it. So these are some of the examples, but we will consider it in the form of the program, and we will discuss later. We will discuss programming examples. We will have a separate programming session. So in that I am going to discuss. Okay, these programs also which I have mentioned, they will be discussed then. So fist is more powerful than individual fingers. So be strong.